I want to make one thing crystal clear. The title and the thumbnail for this video are not clickbait. In this video, I will teach you how to implement a collaborative filtering recommender system with Excel using Cosine Similarity. A relatively simple, but yet powerful recommender system using just trusty old Excel. Now here's the best part. Are you ready for the best part? It's not all that hard to actually implement. Conceptually, collaborative filtering recommender systems are not that complicated. And the cosine similarity math also isn't all that difficult because I will show you how Excel does the cosine similarity calculation for you in a nice and easy way. So this video is going to use a hypothetical example which has kind of become the de facto standard, which is a collaborative filtering recommender system for movies. Okay, so here we have my contrived example, which is the world's smallest movie streaming service. So think of something like Netflix or Hulu or Amazon Prime or Disney Plus. I mean, you name it, right? So many services these days. This particular service has only 6 movies in the catalog. The Godfather, V for Vendetta, Rogue One, Steel Magnolias, Sleepless in Seattle, and Return to Me. So we're going to use a classic example here from collaborative filtering recommender systems, which is we have a collection of products and we have a collection of users. We allow them to give ratings for the various titles of movies that they see, and then we use that data then to effectively recommend new movies to our users. And the easiest way to demonstrate this is with a table. And what you can see right here is a bunch of users, right? We have Dave and Erica and Rob, Jason and Shannon. And just so that you're aware, the Dave here is me, okay? So this first row of data is actually inspired by me. And we're going to use a classic scenario here, which is users can rate movies based on a 1 to 5 scale, 1 meaning they didn't like it so much, and 5 meaning they absolutely loved it, and then everything in between. Very common type of scenario. But know this, right? I just want to make sure that we're clear on this point. The fact that I'm using 1 through 5 scales is just purely an arbitrary decision. You can actually use all kinds of data to implement collaborative filtering recommender systems. So think of YouTube, oddly enough, or maybe not, as an example. YouTube might use thumbs up or thumbs down, 1 or a 0. They might use how long you watch the video, either in terms of percentage or in terms of the absolute amount of time. They might actually track whether or not you opened up the video description to actually see more of the video description or not. They might record all of that data as indications of user preferences. For example, if I watch an entire video, I open up the details and I read the whole thing, I like it, I add a comment, that's telling YouTube that I really like this video because I engaged with it at a high level. The whole point is that you just don't necessarily need to use ratings, but we're going to use ratings because that's the classic example here and it's very easy to understand. So what we can see here is I've seen The Godfather, I've seen V for Vendetta, I've seen Rogue One, I've seen Steel Magnolias, and I've seen Sleepless in Seattle. And I rated all of them 5, which by the way is absolutely true. I love all these movies. I love Rogue One just as much as I love Steel Magnolias because I do love a rom-com. Oh, and by the way, just so you know, I've also seen Return to Me. So this is actually contrived. I would also rank this a 5. I like this movie as well. Anyway, so let's say hypothetically speaking, I haven't seen Return to Me. And what we would like to do is provide a prediction as to how well I might like the movie and then determine whether or not I recommend Return to Me. So to myself. I'm losing a little bit here, sorry, but hopefully you're following along. And then you can see here we have Erica and Rob, Jason and Shannon, and they have their individual ratings of the movies. So what we do here is very, very simple conceptually. It's a key idea. What we do is we go through all of our data that we have in our database or our Hadoop cluster or whatever it might be, and we say, look, of all of our users that have seen Return to Me, right? Because we're trying to recommend Return to Me to Dave. So we need to find all the people in our database that have seen it and then compare each one of those people to Dave, to me, and see how similar they are. The idea being that if we pick a certain number of people that have seen Return to Me and are very similar to Dave in terms of rating movies that we've both seen together, then we can use that data to then create a prediction for how much Dave is going to like Return to Me. So in this case, for example, what you can see here is that all of the other folks, all the other users have seen all the other movies. right? So this, once again, this is a contrived example, but if you have a large enough database of users, you're going to be able to find enough users that share all the same viewing habits that I have, like they've seen all 5 of these movies and they've ranked them and they've also seen Return to Me. Okay, so we've got our base data. So it's a very easy idea conceptually, right? This is what's known as user-user collaborative filtering, which is we take our user data and we take all of their data, all their rankings, all of their indications of how much they like something, and then collaboratively we use that data to then say, hey, Dave is probably going to like Return to Me at this level, and we should decide whether or not we should recommend this movie for him to watch. The whole idea of collaborative filtering, and again, this is user-user. There's also another kind called item-item, but we're not going to cover that in this video. We're just going to stick with user-user collaborative filtering. So the core idea is this: how do we actually calculate similarity? How do we define in a standardized way that Dave, based on his history of watching movies and rating them, how do we know how much alike he is to Erica or Rob or Jason or Shannon? So that is the heart of collaborative filtering, is defining a calculation, defining some math that allows you to take these rating scores and then say which of the users are most like Dave. One of the most common mathematical implementations of collaborative filtering recommender systems is a calculation known as cosine similarity. Now, cosine similarity is actually a very useful thing. Not only is it used in collaborative filtering recommender systems, it is also used, for example, in text analytics for classifying documents. It's also used, for example, in search engines. So if you imagine like a blog post, it's got a bunch of words on it, you can turn that into a text matching type of problem. I type in a search query in Google. Google then says, what's the cosine similarity between that particular search term and a particular blog post? If it's really, really high, then I maybe return it back as a search result. Now, granted, everything that we're talking about right now in this video are the basics. The Netflix recommender algorithm is way more complicated than what we're talking about here. However, these ideas are the basis for recommender systems. So cosine similarity is a way that we can define like between users in our movie recommender system in a standardized mathematical way. And it's actually quite simple. All we need to do is think back a little bit to our days in geometry, but don't panic. It won't be difficult, I promise. Let's start with a very simple example, because this will cement the idea conceptually, and then we can talk about what it means in a more complicated scenario. So first up, we're going to use a chart. We're going to use a graphic here. And what we can see here is a very simple two-dimensional chart, right? I got an x-axis here, and I got a y-axis here, 2 dimensions. And what I'm going to place on this chart is Rogue One ratings, 1 through 5. And then I'm going to apply Steel Magnolia ratings 1 through 5 on the y-axis on the vertical. Very simple. And then we can say, hey, let's plot Dave on this chart. We can go back to that table of data. We can say, where would Dave sit on this chart? And it's pretty easy. Dave sits at the very, very top because he thinks that Rogue One is awesome, and I do. It's my favorite Star Wars movie. So I rank it a 5. So I'm here on 5, right? That's the first part. And then I love Steel Magnolias, right? I do. I've seen Steel Magnolias many times. So I rank it a 5. Not surprisingly, if I'm interested in finding users that are most like me, I can also plot other users on this chart as well and see how things turn out. So for example, we can take Erica. Now, Erica likes Rogue One pretty well. She ranked it a 4, which is quite high. So she's a big fan, relatively speaking, of Rogue One. However, for some inexplicable reason, she's not such a big fan of Steel Magnolias, which is hard to believe. It is an awesome rom-com kind of movie. We've got this kind of graphic. And here's the cool thing. This is where the geometry comes in. We can draw lines from the origin, right? The origin's right here, the intersection of the two axes, 0, 0. We can draw lines through each of the 2 data points that we have plotted on our chart originating at the origin. And it looks something like this. What's even more awesome is that we can understand the relationship between these 2 lines using cosine, which is a trigonometric function. It's part of geometry. And in particular, what we can do is we could say, look, the angle between these 2 lines are an indication of how similar our users are. So think of this conceptually, right? If this is my line and Erica's line is like this and is really far away, then we're not very similar. But if the lines are like overlapping, they're like right on top of each other, then we have very similar tastes in movies based on the data that's in database table. So we can use cosine to actually exemplify this particular relationship, how close these two lines are together. By the way, these lines are typically called vectors. You can think of them as lines, it's totally cool. So lines that are closer together means two users are more alike. Lines that are farther apart means that the users are less alike. So we can then use the cosine of the angle. But here's the problem. We don't really have lines like this in our data. What we really have is a table. We don't have just two dimensions here. We have Rogue One ratings, we have Steel Magnolia ratings, we have The Godfather, V for Vendetta, and we also have Sleepless in Seattle. So we've actually got a multi-dimensional problem here beyond two. So the question then becomes, how do we calculate the cosine of these lines when we have more than two dimensions simultaneously? And I know that's a bit abstract, so let's go to the next slide and I'll show you what I mean. So here we have a subset of the data, right? So these are the movies that Eric and I have in common, right? I'm just continuing from the last slide here. So you got my ratings and we got Erica's ratings for each of the 5 movies that we've seen in common. Now the question remains, as I just said, is how do you calculate the cosine between these two things? Because notice, it wasn't too bad when we were just considering Rogue One and Steel Magnolias, because that's just a 2-dimensional problem, right? An X and a Y, not that difficult. But technically here we have a 5-dimensional problem. So we live in 3 dimensions. You know, there's height and width and length, or X and Y and Z, depending how you look at it. That's 3 dimensions. And we can, as humans, we think about that pretty easily. But once we go to 4 and 5 dimensions, our brains just blow up. So luckily, there is already a mathematical calculation that we can use to define the cosine of complex data like this. And in this case, we have a vector, a line, in 5 dimensions, and then another vector or line in 5 dimensions, and we want to calculate the cosine between them. Okay, so I'm going to show you the math. Just bear with me, okay? Don't click away. Don't click away. So here's the math for cosine similarity. Cosine similarity is equal to the cosine of theta, and then there's all this junk, and then that boils down to this junk here, okay? All this math stuff. It's cool stuff. I'm not going to go through it in detail because Excel handles most of this for us quite easily. And like I said, don't panic. Excel's going to handle the math, and let me walk you through how that works. So let's take a look at this top guy right here, right? This is the numerator, the top half of this fractional calculation that we need to get the cosine similarity between me and Erica in terms of our movie ratings. So this calculation right here is super easy to do in Excel. All you need is the sum product function. That's it. One function handles all of this math right here. And let me explain to you very quickly how the sum product function works. So basically what it does is it says, okay, I'm going to take these 2 cells, multiply them together. I'm going to take these 2 cells and multiply them together. And then I'm going to add them. And then I'm going to take these 2 cells and multiply them together. And then I'm going to add it to the previous sum. And then I'm going to calculate these 2 guys by multiplying them together and then add that to the current sum. And then lastly, I'm going to multiply these 2 guys together and add to the current sum. That's all it is. This is also known as the dot product, but in Excel terms, it's the sum product function. Easy peasy. And later on in the video, I will actually show you an Excel spreadsheet where this is actually done so you can see it in action. Okay, so that's the first part. And this stuff down here also isn't super complicated. All we need is 2 Excel functions to implement this chunk. And then, of course, we would duplicate it for this chunk here because they're basically the same. So what does this say? Hey, do the sum squared function. So what this would do is this would say, okay, cool. Square this value. 5 times 5 is 25. Cool. Square this value. 5 times 5 is 25. Add them together. 50. Square this. 25. Add it to the 50. You get 75. 100. 125. That's it. Okay. That's what sum squared does. Real super easy. And then lastly, we do the square root function because that's what this radical thing is here. That's a square root. And we just take the square root of that. Done. Easy peasy. That's all you need right now to implement a collaborative filtering recommender system with Excel using cosine similarity. That's it. So let's move on to actually seeing it implemented in an Excel workbook. Okay, I'm in the Excel workbook for this particular video. By the way, if you want to get the Excel file, you can find a link to the GitHub repository in the description below the video, and then you can just click on that link and download it if you would like. Also, if you're liking this content, if you're finding it useful, it would be really awesome if you would gift me a like here. And that would just tell the YouTube algorithm that this is good content that other folks that are interested in Excel analytics might find useful. Okay, so here we are in Excel. And what we can see here is the data that we saw from the PowerPoint. Okay, it's the same table. We got the movies here, we got the users, and we got the numbers. So the first thing we need to do is we need to calculate the cosine similarity between Dave and Erica, Dave and Rob, Dave and Jason, Dave and Shannon, and then rank them to see which users are most alike. Now remember, we're only going to be using these columns here because those are the movies that we have in common. So let's see how that works. So we can see over here the calculation, and it's real super simple. Right, so what I've done is I've broken it out into this little table of data here where I've got the numerator, which is that top part of the calculation, and then the denominator, which is the bottom part. And you can see right here, I'm using the sum product function, and I'm saying hold Dave constant here, the blue right here, hold Dave constant with the dollar signs, and then compare him to Erica's data, which is here in the B. And then if I check the next one down, notice that all I do is I switch over to B4. So I've just gone down a row. And then I switch over to B5. I've just gone down a row. And the calculation's real simple. I just enter it in once up here and just drag it down, calculate it all. So these are the numerators, right? So this is the top. Now the bottom, no problem. I just first thing I do is I calculate sum squared here, right? And I'm using myself again, Dave, as the reference point because that's the person that we're interested in comparing to. So $B, $2 through $F, $2. So we do a sum square on that, just like we saw on the slides. And then we multiply it by the person that we're currently looking at. In this case, it's Erica, because she's B3. That's where her data starts. Once again, if we go look at the next one, it looks basically the same, except for now I've switched over to Rob. So once again, I just define this equation once up here, and I just drag it down, and then I get the denominators. And then the similarity calculation is simply this divided by this, and then I get the similarity calculations. And I just added for Grinzies, I just added by hand the rankings here. So based on the ratings of these 5 movies, right? The Godfather, V for Vendetta, Rogue One, Steel Magnolias, and Sleepless in Seattle, I am most like Jason in terms of ratings. He's most similar to me. So we should use his recommendation for return to me for how much I might like it. Now, when you've done these calculations and you've got these rankings, now notice, again, this is a contrived example. It's a very small set of data. In a big company, you would have maybe thousands of rows, maybe tens of thousands of rows of data that looks a lot like me in the database. So what you need to decide is, great, how many people am I going to try and match up to Dave? Am I going to use just the top one and say, hey, the person who's most like Dave, we'll just use their rating for return to me and then make that Dave's prediction in terms of how much he would like it? Or do we use the top 2 or the top 3 or the top 4, so on and so forth? Now, in this particular case, what I've said is, okay, given this very limited set of data, we're going to use the 2 users that are most like Dave based on cosine similarity, and then average their ratings and use that as the prediction for how much Dave's going to like it. So in this case, the top 2 are Jason, right? Jason at 0.97618. And then number 2 is Erica, oddly enough, at 0.973. And Erica ranked return to me, she rated it as a 5, and Jason rated it as a 4. 4 plus 5 is 9, divided by 2 is 4.5. So if we use the top 2 as the basis for creating a prediction of how much I would like return to me, we would get 4.5. Alternatively, if we use the top 3, that would be Jason, Erica, and Rob. And we would see here 5, 3, and 4. So it would be a total of 12 divided by 3, which gives you an average rating of 4. And that's what we would see. Now, if you've ever used Netflix, back in the day, this is what Netflix actually did. They actually had a 5-star rating system, and you would have yellow when you actually rated a movie, and then there would be red when Netflix would show you a movie and say, look, we think you'd like this at 4, 4.5. Now you kind of know how that happened behind the scenes. The Netflix algorithm is far more complex than what we're seeing here, but this is the fundamentals. These are the fundamental ideas of what's going on. This is easily done in Excel, but as you might imagine, Excel only goes so far. If you've got 10,000 movies in your catalog and you've got 1 million users in your database, You're not probably going to use Excel for this, right? You're going to have 10,000 columns, you're going to have a million rows. It's just unwieldy. So you can certainly do recommender systems as I'm demonstrating here in Excel, but eventually you run out of steam. Excel just doesn't scale that well. So if you're interested in doing this sort of thing and you need more power, but you've never like written in any sort of programming language before, what you're going to want to do is check out R, because R programming is easy for Excel users to learn, and R has built-in functionality for doing recommender systems just like we see here, and even more sophisticated sorts of things. So if you're interested in learning more about how easy R programming is for Excel users, just go ahead and click up here and you can see one of my videos on my channel that tells you all about that. Just so you know, there's another way to actually implement recommender systems that is quite common, and that's what's known as association rule mining. And if you're interested in that, I'll put up a video that I have on my channel for doing association rule mining in Excel, either here or here. Collaborative filtering recommender systems with Excel using Cosine Similarity. Excel can be all the tool that you need, and if you need more power than what Excel provides, you can use your Excel skills to leverage R programming, for example, and really ratchet up your recommender system game. Until next time, please stay healthy, and I wish you very happy data sleuthing.